Algebra 1, Lesson 95, the graphs of nonlinear functions, and then recognizing the shapes of various nonlinear functions. So a nonlinear function is a function that doesn't make a straight line. So really quick examples of nonlinear functions would be something like this, or something like this that goes in that direction. We could also have, let me see here, we can also have ones that go like this in straight lines, all right? That, in case you couldn't tell, the first one is supposed to be a U shape. It's supposed to be curvy. We also have, we've got crazy ones that go like this and change direction. And then we've got even crazier ones that will change more directions, like 3 times. They'll go like this, right? So we got all kinds of crazy looking functions that we can graph. And we're going to learn how to do that today. But first, let's go to our book. Okay, so we'll turn the page. And we'll demonstrate this. We'll demonstrate one of these functions and why they make funny shapes. We'll start with, we're going to do square root or cubic. We'll just do the x squared function. No, that one's boring. We're probably going to do it in class anyway. I'll do, I'll do x cubed. All right, so we'll make an x and y table. We'll do the graph of x cubed. So the function we're graphing is like this: y equals x cubed. So if we make an x and y table to graph this, and we start picking some numbers. Now, normally when you're graphing nonlinear functions, you want to pick 5 numbers. The reason being, it's going to make a curvy shape, and the best way to figure out the shape of the curve is to use 5 numbers. So I'm going to pick 3, 1, 0, -1, -3. Those will be my 5 numbers, and I'm going to test them in this function. So if x is 3, then 3 cubed is going to be 27. So if x is 3, then y is going to be 27. Maybe 3 was a big number. Hold on, let's see here. Do I have 27 spaces? 3, 6, 9. No, I don't. Let's just do 2 then. We'll make it +2 and then -2. So that number was too big for my coordinate plane. So let's say x is 2 cubed, y is going to be equal to 8. Now if x is 1, 1 cubed is going to be 1. So y will be 1. Now, if x is 0, 0 cubed is going to be 0. Now, -1. Let's take -1 cubed. And that one can be a little tough with a negative, so we'll go ahead and multiply -1 times -1 times -1. That gives me +1. +1 times -1 gives me -1. So, -1, -1. -2 cubed, the last one. -2 times -2 times -2. And that gives me -2. Or sorry, -8. 2 times 2 gives me +4. 4 times -2, -8. So I'll go ahead and erase all this work up here, and then we'll graph what shape this makes. So starting at 2, 8, go over 2, I go up 2, 4, 6, 8. That's 1 point. Then at 1, 1, I have another point there. At 0, 0, I have a point. -1, -1, I have a point. -2, -2, 4, 6, 8. I have my other point down here. So the graph that this makes is a curvy line that looks like this. All right, so that's the graph of x cubed. And that's how we figure out the shapes of nonlinear functions, is by using 5 points, plugging them into the equation, and making an x and y table. Now, we have to learn how to recognize the graphs of specific functions. So, first is the graph of x cubed. X cubed normally makes a function that looks kind of like this, right? So it's going to start in one direction. Usually it'll pass through 0. Sometimes it'll pass through somewhere else, and then it'll curve like this. Now the graph of x cubed can be moved. It can be shifted up here to where it passes through a number taller than 0. It can be widened out like I did with this one. It can also be moved over here where it could pass like that at the midpoint, right? So the graph of x cubed just is a curve that changes directions and then curves in the opposite direction. Now let's talk about the graph of x squared. This is another one we have to memorize. The graph of x squared makes a smiley face or a curve like that. Now the graph of x squared can also be reversed to make a frowny face. This would actually be the graph of negative x squared, right? And then likewise, the cubed function can also be reversed. So x cubed would be like this, and then negative x cubed would look like this. It would go in the opposite direction, right? So that's x squared and x cubed. Let's find the other ones. Let's see here. We also have the graph of the square root of x. So the square root of x starts at a single point and then curves in one direction like that. Now the negative square root of x would start at a point and then curve down like that, right? So these are two different graphs right here. This one being x squared, and then the bottom one that I just erased would have been negative x squared. Let's see here. Next we have the graph of absolute value. So the absolute value of x is going to be two straight lines that go in 45-degree angles like this. And then if we were to do the negative graph of the absolute value of x, it would, so I'll draw this in green so that way we don't get confused, would do the opposite. It would go down. So you can see that negative functions, they just make the same shape, but they reverse them in the opposite direction. Let's see here. What else are we looking for? Oh, quadratic functions. So the first graph that I showed you, x squared, if it were a quadratic function like x squared, let me find one. Okay, like this one, we could have x squared plus, or sorry, x squared minus 6x plus 9. That is a quadratic function, and it would actually make a smiley face, which follows the graph of x squared. So if you have multiple variables in your function, you go with the highest exponent, and that's going to tell you what shape it makes. So like for example, if we had the graph of y equals x cubed minus 2, we look at the x cubed, that tells me that the shape is going to be like this. And this one right here is the graph of x cubed minus 2. So when you have more information in the graph, you just look at the x and what's happening to it, and that tells you what shape it's going to be. The other numbers will change the shape. It'll either widen it out or narrow it or move it left and right up on the graph, but we don't have to learn about that yet. We just have to learn the shapes of them. I believe that's all there is for this lesson. So a little bit of a long video, but it's good instruction. That's all there is for now. If you have any questions, let me know on Moodle, and I will see you in class.